Hello, welcome to tutorial 9, where we're recreating Minecraft using Python and Peter Amlan's wonderful Ursina engine. Um, his flash screen just appeared. Right, in this in this video tutorial, I'm going to show you how to get um, model animations working, like our friend here, who now has a name. I'll reveal the name shortly. Guy has named our panda. If you haven't seen this creature before, this mob, you may be confused while I'm calling it a panda because someone textured it. It might have been me. I can't remember. It's not important who textured it, but it does look a bit like a cow pig and not a panda. Obviously, panda, I know this, of course, have white bodies with black limbs, a white face, and famously, like black patches around their eyes. Whoever did this, I don't know. Don't know what was going through their mind. Anyway, what you can see is that the feet are moving. Very simple animation that I've created. But everything I'm going to show you here are the fundamentals for creating your own mobs, your own mob animations, and then importing them into Ursina, so you can use Python to get going. Obviously, what I've done so far, and this is the extent of it, is very simple. Because to do anything really in this world well, you have to put some time in. And animating actually and texturing for that matter is quite fun if you have the time to do it. Um, anyway, you can see his little legs, and if I just do some building, whoops, wrong block. That was a bit rude, wasn't it? Oh, that was possibly even ruder. There we go. Now we can see once he's stopped. Actually, this shouldn't be taking place. Oh, once he's stopped, I didn't realise I had already prepared this. Once he's stopped, you can see that the animation has stopped as well. Now, if I move backwards, the animation starts again, and he walks. So what we're doing is syncing our animation with the kinematic movement of our object. So let's get started. I'll show you how to do that. Oh, actually, while I've got this world loaded, a couple of other things to show you. If I just build a little wall for myself. Actually, if it's 2 blocks high, I think this is the same as Minecraft, we can step over it like that. Lovely. And we can even show off and go backwards. Look at that. Brilliant. We've got now a giant panda in the way. Oh my god, they're just looking at me. So, but if I do 3 blocks high, then I can't now get through it. And by the way, I really like this. It creates a real sense of this world being real, which I didn't anticipate. It's just made it a lot more immersive, I guess, which is very interesting. Anyway, I've also got this behavior, this solidity, working for strafing left and right, like that. And also, if we go backwards, I guess you have to trust me. I can't get through the wall. There we go. So, we've got that working. And another thing, we can now save terrains, load terrains as well. So, in upcoming videos, I'll go through those. The collisions of walls and things like that, and also saving and loading. Right, so, but this video, we're on mob models. Yeah, so the name of the panda, in honor of Guy, he's named the panda Greninja 28 or Grey Ninja 28. I guess he says that's brilliant. Oh, let's add a thumbs up. There we go. Very good. Sean is asking about could I explain how to do a 3D engine and how that works. That's a bit beyond my pay grade, actually. I don't know. I'll look into it, Sean. Um, But no, I won't. I won't look into it. That'll take me too long, and I need to dedicate all the time that I've got to these videos. I'm afraid. So that no, that probably won't happen, Sean. But if you've got any suggestions, Sean, about what I could look into or what you're particularly interested in, then I will. I'll try to reply, and anyone else who knows of any good tutorials on 3D engines, pop them in the reply here to help our buddy out. Oh, I can't remember his name. I think is it the Cherno? The Cherno, he makes his own 3D engine. It's not with Python, however. It'll be C++, almost certainly. Anyway, query. So in response to this, I've sorted out the collisions for now. I think that's what you were asking. And then who was it? Oh yeah, Coding Mania. What about adding animation to the mobs? And that was 6 days ago, so just under a week. So I've tried to make this video and then it all went wrong. And then I tried making it again, and I was holding my chihuahua, and then my chihuahua knocked my hand. And would you believe it? There's actually on this drop down menu, you can actually go to cancel recording, which I did. So a chihuahua erased my earlier attempt at making this video, which was just devastating. So it would have been with you sooner. Right. So first thing, if we go back onto Blockbench, so in the last video, video 8, I loaded in the Minecraft Panda. And what we're essentially going to do is export a separate OBJ file. So an OBJ file is a 3D model file for each important part of your animation sequence. You might call that a keyframe. So if you imagine you having lots of frames making up an animation, such as, I think I've got one kind of prepared. Oh my god, this is almost professional. No. I want to calm down. I don't want to be professional. It's kind of my rule just to make stuff up as I go along. So play the animation. There we go. So an important frame might be this first one, like our starting our starting keyframe. And then if we play and then pause about there, like the final frame might be the important one, the keyframe. So I could export a model here and then export this model, and then I've got my 2 frames that will make up my animation. Now, you don't have to make your animation sequence out of just 2 frames. A really good one will make it up of several, so you've got some smooth movement. Or later on, we might develop a system where we just put in this frame and this frame, that frame, and then we'll use Ursina and Python to linearly interpolate all the rotations and things. And then I think Minecraft, it uses like JSON files where you can like code how much rotation and if it repeats and things like that. And you could even have some selection in there, so some decisions about when certain animations will happen. So we might develop that later on, but as you can see, it's like its own little project. That'll take some time. Anyway, we're just going to get some stuff done quickly. So how do you export this? So I'm in the Animate tab or area within Blockbench. And what you can do, let's say you want that frame as one of your keyframes. What you then do is go to the animation menu and then go to bake animation into model. There we go. And actually, I think it explains what that is itself. And you'll notice that we've gone back into the edit area now, or rather Blockbench has now put us in the edit area. And you'll notice that its head, our panda's head, has turned to correspond to that keyframe. In other words, it's just made the adjustments to our model itself. So now when we go to File, Export, OBJ file, so not GLTF or Collada model or Sketchfab or Share, go to OBJ model and export it. That will download a file to your computer that you can rename. It will be there. Anyway, if you hadn't, let's go back into Animate. If you hadn't gone to Animate, the Animate menu, and then Bake Animation to Model, when you export it, even if you've paused your model, say there, when you export it, it won't look like that. It will export, if we go back to edit, it will export this version here, which actually looks very similar. What if I take it all the way back? And can I use some rotation? Oh, I've forgotten. Yep. Let's rotate it there. When I go back to edit, yeah. So when we go back to edit, you can see it's got the orientation, the rotation of the last thing we baked. So if we go back to animate and we want this version, again, we go to animation, and I'll just read out actually bake animation to model. It says bake. Can I zoom in? No. Oh, that zooms in everything but the thing that I want to read. Bake the currently displayed animation frame into the model. Only applies rotation, position, scale. Scale is ignored. Okay. So let's bake that. Bake, and then it takes you automatically into the edit area where now I can manually export it. Done. Now, you might be thinking, what if I want a complicated animation with lots of frames to make everything smooth? And that's going to take a long time, and it will, to do that manually, if it's very complicated. If it's just like a walking movement, like I did, it won't take you very long. It took me about, under a minute. All I did was, I didn't even go to the animate, I just did it in here. I moved that leg, got hold of that leg, done. So I went to File, Export, OBJ model, lovely, and then you could even do Control Z. Oh no, I did that last video. How do I undo? There's an edit, undo. There we go. Edit, undo. Right, and then now that I've got the legs in this position, and remember I'm in the edit mode, so I don't have to bake this. By moving stuff here, you are baking it into the model. You're acting on the main model itself. So then I could go to File, Export, OBJ, and I've got my two separate models that look slightly different because of their legs. Done. Takes about a minute. Now, where are you putting those? Oh, before we get to that, sorry, I was just going to say, I think, I haven't tried it out myself, but if you use Blender, a very popular free 3D modeling software, it's very powerful. You can do animations in there, modeling, of course, texturing, Perlin noise, loads of things in there. I think there's an option there to export an animation, so you can do animations in Blender as well. So you could do a whole complicated walking sequence or an attack sequence or something nice sequence, and then you can export, I think, automatically all the different frames as their separate OBJ model files. So check that out. If anyone knows that, if you could put in the comments to this video, that would be really helpful to everyone. Okay, so what do we do with the files once we've downloaded them? Well, here's our main project folder with main, our mesh terrain, our Perlin, all our old friends, and our assets folder. So in assets, you put your basic model. There's our texture atlas for the terrain textures, our snowflake, and there's the panda model, which I did, and the panda texture, which someone did last video. I've also got, and the sounds. I've also got now an animation test folder. So really, these should be separated into sound folder, texture folder, and so on. Anyway, I've done a few tests. Here we go. Ignore all those at the top. But these two, you do something like this. So let's say you've got two keyframes in your animation. So I've got a panda walk 1 OBJ and a panda walk 2. So the names of these are really important. You must name them exactly the same way and then number them sequentially as they appear in the animation sequence. So my first one, if I open this up, I think I can open it up in preview on a Mac. Open with preview. Have some coffee. Might take a down. There it is. Looks like a polar bear. Polar pig. Oh wow, look. If I let go, it kind of spins. Nice. So this would be my panda walk 1 because he's not really moving his legs yet. And then the next one, open with preview. and then spin him around. There are his legs. So that's keyframe 2. So then let's go, we're finally into Ursina and doing some coding. Then let's just quickly show you the mob system. So we're going to build this module, and all we have to do is, let me write this properly, panda walk underscore. So I'm not going to put the 1 in here. You're just going to put the first part of the file name that's common to all of the keyframe models that you want to be part of that animation sequence. So let's go back to the files themselves to remind you. So it's panda underscore walk underscore, and then they're each going to have a number, 1, 2, and so on. So there you go. So you just put the stem of the file name. Now what this wonderful function does, frame animation 3D, it's just like creating an entity. So instead of guy, or what's his name, Grey Ninja 28 equals entity, and the model being this, we're just going to go to use frame animation 3D, and then not set a model. So we're not going to say model equals that. We're going to say look for these files, which are the models, any of them that you find, and there could be hundreds of them. Ursina will automatically load them as entities and then start animating them together. Right, so that's the idea. Let's go and actually do some coding. So last video, here's our main module. It's getting close to 100 lines, so we're going to sort that out. Down here, we've commented mobs deserve their own module. So let's do that. First job, let's go to File, New File, select a language, Python, and then save this as, we'll call it mob system. There we go. Mob underscore system. Good. So we've got an empty module ready to put our mob stuff in. And actually, let's just take all of that code, those 4 lines, including 2 comments, and drop that into our mob system module. Now, since we've just done that, here is the place where we're creating our mob in the first version of our code. So we'll say from mob underscore system import asterisk, meaning everything. So it'll just import all that code in the same way. Now, not making any changes. However, it won't work at the moment because this module doesn't know what an entity is or a vector3 object. So let's just do this. Let's say from Ursina module, just import everything. That will be helpful. With something else later on. You know what? I won't make any more comments. That's fine. We'll just do that. Okay. So what we really should do then is delete all of that. And our name's not Guy. We'll call him Grey Ninja. Was that right? Ninja 028. I think that's right. Grey Ninja 028. And because that's far too long, we'll just use a nickname, Grey. There we go. With the English spelling. I hope you don't mind. So Grey equals, what does Grey equal? A frame animation 3D. And then we want the stem of our model. So panda walk underscore. Right, the next argument we can pass in is the frames per second. So how many frames do you want to display per second? Let's not put in anything yet. The default, you can see, is 12. You may have seen the other default things, settings, properties. Loop is going to be true, so it's going to loop over and over the animation sequence, and also it's autoplay. We won't worry about anything else. So if this works, we should have our panda walking immediately. And now we want to change Grey's position to the same place we had our panda before. Lovely. Let's just put this comment at the head of this module. Mobs deserve their own module. I can't resist a terrible pun. I don't care if this is cringy. Mobule. That genuinely made me very happy. Okay, from a can't laugh anymore. You know, there are limits. Grey equals very much. So, just treat this like the entity object, but it's doing something very sophisticated. It will just hoover up, vacuum up all of the files, the object files named in sequence. Okay, good. Right. So, is that working already? So we'll go back to our main module and run things from there. How has it already been 20 minutes? That's incredible. Here we are. Whoops. Okay, we've got some bugs, which I look pleased about. It means that I can teach you how to get over these bugs, which could be frustrating, because you might not be doing this, but you might be doing something else using audio, whatever's happening here, and so it might help you out. Anyway, module object is not callable. Grass audio pitch, which is very weird. And this is a classic kind of bug situation where we've done something to do with mobs and animation. We've done nothing to do with changing any of the audio, but something's gone wrong with the audio. So, what I think has happened, because I think it happened to me in my preparation, is that when we're importing everything here, we may be importing something to do with the audio. That's overwriting something that we did in our main module. And in our main module, in fact, we have got control over our steps at the moment. This all needs to be refactored and placed in its own module that's dedicated to sound and audio, so that we can cleanly overcome bugs like this without going to the main module and getting tangled up. Anyway, it's okay. It's okay. So what I think is happening is, yeah, it was saying something about random pitch, wasn't it? It was, I've deleted now the console, but yeah, it was this line, I think. This line or this line, where we're using random. And I think whatever we did here, probably because of this import, there's a conflict between this random namespace. So, one fix might be, let's try this. We'll say import random as R, or Ra, I should say, like the Egyptian god, Ra, and then when we're using random down here, we just need to refer to that module, Ra, and now that should overcome any conflict, I think. Let's just see if we're not using random anywhere else. Anyway, save the main module, save our lovely new mob system, module, and play. Just see if that happens again. It's taking a little while to load, isn't it? Because I'm loading up quite a lot of terrain and it's auto building. Okay, we've got foot sounds and it's not crashing. So before, as soon as I moved, it was trying to run that random line. Anyway, so that's how to overcome that bug, done. So we've got some success. We've got our panda model. Not a panda model, it's a sequence of panda models with one line, and they are animated. Lovely, so it's running. So what we have to sort out is the texture and to slow down that animation. So let's do the texture first. That should be the easiest thing. So we can, once we've created our animation sequence, we can then say, Grey, your texture equals, I think it was panda underscore text. And then since we're here, now we can use our frames per second equals, let's just try 1 frame per second. Go back to the main module. Oh, and then let's just sort out loading. Generating terrain will say false. And what happens if I just generate 12 terrain chunks? Is that enough room for us to debug and develop? Okay, so it did load a bit quicker. Okay, we've got a little bit of room, and we've got a texture, and we've got some animation. Lovely. Good. So, exciting things. I love writing like AI and I'm not talking about machine learning, just which, you know, also love, but AI in the old-fashioned sense, just you know, arcade style movement behaviors of your mobs and creatures and non-player characters, etc. There's something magical about it. But let's go into our mob system. So what we want to do is, from our main module actually, in our update loop, so our main game loop, let's say after the terrain has updated, we'll say, let's say handle mob AI, and then we want to say something like mob underscore move or movement, mob movement. We might need to pass something into there. If we want, for one of our behaviors, I've just got one behavior at the moment, which is our mob will turn towards our player and then move towards them. And actually, if they get close enough, they'll stop. And they'll stop their animation sequence. And then they'll start it again once they try to follow the player. So we need to know where the player is. So we've got to pass in the subject's position. So subject is our player, dot position. And also, you'll notice that our mob was moving up and down on the terrain. Even when I built terrain underneath, it was reacting to the terrain. Good news, we can just copy and paste this lovely system that we've got down here for our subject. And we just need to change a few variable names. Brilliant. Okay. Oh, we also need to say, well, what mob do you want to move? So we want to move grey, which is a bit confusing because grey doesn't exist, as it were, in our main module. But remember, the main module is importing everything from the mob system. And grey is a part of the mob system, so we're importing everything in there. Now, later on, when we develop this, we'll probably create an object, a mob object, so we can create thousands of mobs, different kinds of mobs, loads of animations and things, and handle that all easily. At the moment, we're just building things up as we need them, tiny step by tiny step, which I would recommend for keeping your code as simple and manageable as possible in terms of debugging. Right. Where were we doing? Because the temptation is to just generalize straight away, and you can see what you're going to do in the future, and then try to build foundations for that. But you can get into problems. Right. What were we doing? Oh yeah. So we want a function called. So we define a function called mob underscore movement, and then we're not going to write this or self because we're not writing a class here. It's just a standard function. What did we pass in first? Yeah, we wanted the mob, so we'll call that mob. And then we want a subject position, so we'll call that subpos. And then we do need the terrain dictionary, don't we, to walk up and down the terrain dictionary. So I'm going to put an underscore there and td. So just to remind myself that this isn't the actual terrain dictionary. This is just the current copy, a temporary copy of it, as it were. Which I don't think I passed through as an argument. No. I put a comma there, though. and then so the terrain dictionary is a member of the terrain, a property of the terrain object, TD. There he is. So we pass him through. Right. What's the first thing that we want to do then? The first thing that we want to do is get Gray to look towards the player. Now, Ursina would do this way. So remember, although we're talking about, Gray, it's whatever mob we pass through. And remember, we've passed through Gray. So we want to generalize though. We want to say, well, mob, we want to look at, so that's the Ursina function. And all we need to say, what we need to say here is what entity. So, or what entity, no, it might be the actual entity. So we'd have to put the subject in here. However, I think it's better for us to use the look at, which is a different function. So capital A, it's using camel humping. What do you call that? Style. Convention. And I don't know where this comes from. I think it's a function on the Panda 3D, ironically enough, because we're moving a panda around, module, which is what Ursina is built upon. So we're kind of going underneath Ursina here, I think. Anyway, I'm using this one because we can definitely just say, I want you to look at this sub position, which is a vector 3. So this is doing some vector math for us. It's just saying look towards, or create a vector, a heading towards some position. But then what we can do with this look at is then specify a speed. So we could say what that mob's turn speed, and then we want to multiply that by, can you guess? This mob movement is being called in the update loop. So that's going to be time dt. I felt like a teacher there. I was like, can you test your learning, test your understanding. So we're we're multiplying that our turn speed by time delta time, which means it will be the same speed, the same rate, no matter how fast your computer is running, which is good practice. So our turn speed, that doesn't exist yet, but what we can say is, Gray, your turn speed equals, let's say, just 5, a random number just picked out of the air. Now, that's the beauty of Python classes. We could just add on a new property just like that. Done. And that now exists. Turn speed is a part of this object. And so that's being used down there. Good. Right, so we should look at it. Let's go and see if this works. 33 minutes. I've hit half an hour. Fantastic. It is working, but there we go. Can you see what's happening? So we've still got our animation working. So what's happening is he's looking at us. He's doing exactly what we've specified, which is a classic. It's a very unusual species of bug, in that the bug is up here, not in the computer. You had one idea in mind, but then the computer's just done exactly what you wanted. It's taken your words literally. So it's literally turning its entire model to point exactly at your player. So what we could try is something like maybe minusing that position, but maybe that would just point the hindquarters of our mob at our hindquarters. So here's one solution. In the comments, put a better solution if you've got it, but we could just say mob rotate. We want to rotate on the y-axis, so that's the like a pole sticking through us, so that we move like that. Oh, now I want to remember what they. So that's roll, isn't it? That's pitch, the x-axis. Roll is the z-axis, and then yaw, y-a-w is describes that movement. So we're gonna yaw rotate y 180 degrees. So it's pointing at us, but then flipping round. I'm not happy with the turn speed. I want that to be a lot less. So that's one thing. Let's just see. That's one problem. Have we got our panda facing us this time? It's got no attribute called rotate y. What have I done wrong here? Rotation, I think. Rotation. Oops. Oh my god. Rotation on the y-axis. Oh, do I have to say rotation on the y-axis plus equals 180? Is that what I meant? Ooh. Ooh. Hey! He's kind of looking at us. He's kind of looking at us. So we've got his face. We've got his face. Lovely. Again, if your knowledge of quaternion rotation is superior to mine, which it almost certainly is, do explain to me what's going on in the comments. There we go. Mob system. So what we now want to do is, what did we really want? We only wanted our model to rotate on the y-axis. We don't want any z, any pitching, or any rolling. So maybe we'll do that now. Let's do it now. So with translations and rotations and things, it really matters what order you do things in. Anyway, so if something's not going as you want it to, if a rotation's not behaving as you want it to, try changing the order of things. Okay, so we want to say, oh, could I just say mob rotation x equals 0, mob dot rotation z equals 0. Oh, I wonder what I did in my prepare code. Before I look at my prepare code, did I do this? Maybe I could just say rotation. Then I could just say mob. No, I wouldn't have done this. Rotation dot. No, I might have done this. I might have said 0, and then we want mob dot rotation dot y times 108. No, plus 180 degrees, and then 0. That would be cool, and then we don't have to write 3 lines, we get it in 1 line. Is that what I did? Oh look, I created it. I created a vec3. Yeah, I did. So I did the same thing there. Lovely. Does that set the rotation if I just pass it into there? Anyway, let's just see if that now does something. So what we want is the our mob grey looking at us, but without any pitch or roll. No, vector3 object's not callable. So yeah, so mob rotation equals a new vector3 object. So we're creating this new orientation. That was good. We've got another bug. So hopefully I'll help a few of you out if you get a similar thing. Look at that. Oh, perfect. So he's looking directly at us, and we've got the kind of rotation we need. I've also noticed my animation is not as good as the one that I showed you. in the beginning of the video. I've only moved one side of the legs for some reason, so it kind of looks like a bull getting ready to charge, a classic cartoon bull. No, they do that in real life, don't they? Brilliant. Right. So now that our mob is looking at us, we now want to move towards a player. So let's just comment this so we know what's going on. So now move mob towards, we'll call it target. And then first look to, or turn towards target. Good, good, good. So now we want to move towards a target. I've genuinely forgotten how I did this. Let's just let my fingers answer the question. So we just want to go forwards. So mob position, which is it's like this. It's a 3D vector. It's a position vector, so it's just holding an X, a Y, and a Z component to describe its position in 3D space, or its location in 3D space. So then we want to add that to itself, so plus equals, and then the additional thing is it's the way it's facing. Now, notice a problem we had before. When we asked our mob to look towards the target, our subject, it was in reverse. That might happen because, for some reason, in whatever in whatever modeling software you choose, when you load that into your game, it will always be reversed on the Z-axis for some reason. I kind of arbitrarily chosen. So maybe we want to go minus forward. Oh, you might be wondering what this forward is. I think we have used it before in previous. Yeah, we have with the mouse look and things like that. But the forward is just a vector 3 like this. It's a vector 3, and then the components will be made up of numbers that describe the direction of the forward direction of that object. That's what's going on there. So we don't have to calculate that. It's got it built into Ursina here, or rather probably Panda 3D underneath. And then again, we want to say times our mob speed multiplied by time delta time. Good. So mob speed doesn't exist. So in the same way as adding that, Jerry Gray speed equals 5. There we go. So he now should move towards us. Let's have a look. Haha. Oh, I was going to say he's gone. Okay, this is scary. He's way too fast. He's too big. So we've got to slow him down. We've got to slow him down. So mob system speed, we'll say 1. Turn speed wants to be a lot less as well. Can I say like 0.2? Let's have a look at that now. Oh, that's good. So he's moving towards us. And yeah, the turn speed is actually really fast. So can I put 002? Maybe my lookat code is not working at all. Well, my lookout. Yeah, the speed isn't working at all, is it? Let's have a look at my prepared stuff. Yeah, look at mob turn speed time.delta time. Okay, so we're going to have to sort that out. So turn speed not affected, question mark, not affected. So there's a little bug for me to look at. Shall I write bug in capital letters? Oh, look at that. I'm not the first person to think of this, look. But when you write bug, capital letters, it pops out in lime yellow. Lovely. Right. He's moving forwards, but now just going straight through the terrain because we haven't got any subroutine looking after our mob interacting with the terrain. So let's just now, after it's like walking towards us, we'll say go and call the terrain walk. And what we're going to do is just copy in, here's the code from line 70 here, copy in to line 90, so 20 lines of our subject system for walking, and then paste that in there. Lovely. So subject doesn't exist, so what we want to pass in here is the mob, and we'll call it by exactly the same name. So every time we find subject, we want to replace that with mob. I'm not sure if we'll have to do this. What did I do in my prepare code? Step height we can dictate. So maybe our panda could probably climb up about 5. And its height, oh yeah, it's not as high as me. Not that does that matter? What did I do in my prepare code? Yeah, its height is 1. So let's add 1. On step height in my prepare code 4. Okay, let's go for 4. Right, we haven't got the terrain dictionary, so we need to pass in underscore TD. So where we've got TD, we just want underscore TD. And subject down here needs to be mob, mob, mob. We've got a magic number down here, that's not very good. That's kind of the speed of the stepping up and stepping down. Right, TD doesn't exist in this function. So let's just pass through TD. There we go. We can do that here because we've passed it into our mob movement function there as a nice parameter. Lovely. Does that already work? Does that now work? If this does work, that's tempting fate. If this does work, then one more thing. Yes, I can see him reacting with the terrain. Very good. So one more thing I want to do is have him not come so close. It's too intimate, and then we get horrible things like this happening. So we want to say, if you're like 10 units away or something, stop. That's close enough. So to do that, we need to measure the magnitude or the length of our vector. Where are we? Mob system. So we only want to move forward if we want to do if our subject position, so that's our target, minus mob.position. So both of these are vector3 objects, so we can apply arithmetic to them. So if that resulting vector is greater than, let's say, 10, or what should we call that? We'll call that intimacy. Intimacy distance. Intimacy dist. Then you can approach. I'll call that approach target. Else, do something else. I haven't decided what that is, so I'll just put the pass keyword in. Okay, so we need some variables first. So intimacy dist equals 10. Stick with 10. Right. This is going to, the result of this is going to be a vector 3 object, and we just need a number for how long, what the magnitude is of that vector 3. So actually we need to create that vector 3. So we'll say distance equals this. So now dist is going to be a vector 3. So we can say dist, how do we get the magnitude? We just write dot length. That should give us the magnitude. So we can say magnitude of distance from target. It's kind of a tautology. Examined. There we go. Let's say how far away from target. Excuse me. We'll say how close can they approach? How close can they approach? That's intimacy distance. How far away from target? That's what that does. Magnitude of distance from target examined. There we go. Approach the target. Else, don't approach the target. Else do nothing. Now, if this works so far, I better turn some terrain on because I want to walk away from our panda, if I can. So press G to toggle on my terrain. Sorry, it's a bit jolty. There we go. It's following me, moving along the terrain nicely. And then has stopped there. Wonderful. That's a nice distance. If I get a bit closer, he does anything. And if I go further away, surely enough, he follows. Okay. Now, one thing that we want to, the final thing we want to sort out is, notice this little hoof, panda hoof, is moving still. So we want to be able to switch on and off our animations, which is a nice place to finish this video because we started doing, we dedicated this video to object animations. Once again, thank you to Blockbench. Thank you to, where is he? Oh yeah, who named our panda. There it is, Coding Mania. How about adding animation to the mobs? Double question mark. Signaling your enthusiasm. Oh, I haven't done a heart. Love it. There we go. I forgot what we're talking about. Yeah, a nice place to end the video is switching on and off those animations. So, if we are moving the target, then we want animations on. So, I guess as we develop this animation system, we need their own function to deal with this. But at the moment, we'll just do it down here. So we'll say, how do we do this? Oh yes, we just refer to the mob because it is, remember, its object type is a frame animation 3D. So this won't work on a normal model. a normal entity, sorry, I should say, a normal entity, a Ursina entity. Where are we? Here we are. We're in the mob movement function. So you want to say mob resume, and what that means is resume animation. And actually, here's a nice comment. Whoops, I want just the hash. I want to say animation, and then I also want to say mob is playing. I think that's what we call the animation, equals true. That doesn't get. You would presume that the resume. You would assume that the resume function would set that property to true, but it doesn't. It either doesn't do that because there's some deeper reason for how these animation sequences work, which I don't understand yet. I've only looked at this very briefly. Or it's just a mistake. They haven't put that in the code. Anyway, I've put a push request. I've put that into the code. And we'll see if Peter Amland or whomever is looking after that module to do with the animation. They'll either include it in the next update of Ursina, or they'll explain to me why it's not supposed to be there. Or they may ignore because it's a minor issue, I'm sure. But there we go. So mob resume. Right, so else, if we're too far away, then we want to switch off the animation. So I don't need to copy and paste. I can say mob pause. So that's how to pause the animation. And again, let's just animation mob dot is playing equals. I want this equals to be snug. There we go. Equals false. Flays false. There we go. Now, the reason you bother setting these is because you might want to detect whether the animation is happening, because you might not want to interrupt it. If like there's a previous animation happening, you might want to let it stop and then start a new one, or other things. Anyway, I've put that there because it'll be helpful. Right. Let's now see if that all works. Oh, and we might be under an hour. Please let this work. I actually don't want a bug this time. A very rare occasion when I don't want a bug to happen. Okay. I don't see any feet moving. Let's generate some terrain. Oh. I couldn't tell for a second, but it is working, isn't it? It's his right leg. Yes, you can see it moving. It works. Okay. Brilliant. So next videos, it'll probably be how to get the proper collision working. Oh, oh, this is not my prepared code. There isn't. Yeah, so I can just walk straight through walls, glitch through walls like this. So I'm going to show you how to overcome that in the next few videos. Probably the next video. Yes, there we go. Thank you very much. Enjoy the rest of your night or your morning and the rest of your day. Goodbye.